Welcome back to Bargaining in War. In this lecture, we're going to take a comparative static on the uncertainty over spoils game and see what happens when we increase the proposer's probability of victory. You'll recall that we solved that game as a function of Q in the last lecture. Q being the prior probability that A believes that B has a large amount to share. We found a critical cut point, which was CA plus CB over P times 1 minus pi plus CA plus CB. And if Q was above that cut point, A would make the risky demand. It would make an onerous demand, hoping to get the type that has a large amount to share to accept. And in contrast, if Q was below that cut point, it would make a safe demand targeted toward the type that does not have very much to share. So it would make a very small demand in contrast, and so both the types would accept. What we're interested in answering here is what happens when we change this value of P. And if we go back to the two possible equilibrium demands, what defines a safe demand versus what defines a risky demand, we might have some intuition about what we'll expect to happen. So you'll remember that the safe demand was to ask for pi times P plus CB. That's an amount that the low value type is willing to accept because it's basing it off of this pi quantity. And in contrast, the risky demand was to ask for P plus CB, where now A is asking an amount based off of the idea that there's a full value of 1 to be shared between the parties. Well, notice what happens when you set P equal to 0. When P is equal to 0, both of these things cancel out, and A makes the same demand regardless of whether it's trying to make a quote risky or quote safe demand. Both of those things are the same at that point. So we might have an expectation then when P is very small, when it's close to 0, we have no probability of war. And when P is getting larger and larger and larger, we're going to see that risky demand be made more often, and thus the circumstances where we have rejected offers is going to go up. So in other words, what we would expect is that when we increase P, we're seeing more risky demands being made, so that should shift this cut point down. Okay, and let's prove that just with a comparative static. So let us look at the additional amount. So this is when we add a little bit of P. So we're adding epsilon to P, and we're going to put that in parentheses, because notice we have to multiply that entire quantity by 1 minus pi. If we forget to put that in parentheses, we might not get the correct answer. So we have to remember to do that. And we're expecting that that's going to be less than the original quantity when we did not change P at all. So now we just need to manipulate this and see if this is true. Well, what do we have? We have the same numerator, so we could immediately just delete those. We don't have to divide by anything that's negative here. Both CA and CB are positive quantities, so that's going to maintain the same sort of inequality here. We're not going to flip that. P plus epsilon, 1 minus pi, just rewriting those numerator, or the denominators rather. 1 over P, 1 minus pi, plus CA plus CB. Okay, now we can move both of the denominators to the other side. And you'll notice again, this is a positive quantity, that's a positive quantity, because 1 minus pi, well, pi is a number between 0 and 1, so we're good there, that's positive. And positive, positive. Everything here is positive, so we don't need to flip the inequality. So we have P times 1 minus pi plus CA plus CB less than P plus epsilon, 1 minus pi, plus CA plus CB. Okay, we should notice that we have CA and CB on both sides, so we can get rid of those. And once again, 1 minus pi is a positive value, and it's on both sides, so we can divide off, which leaves us with P less than P plus epsilon, and then we finish this proof by noting that not 3, but rather epsilon is greater than 0, which is true. Hooray. So what we have just shown then is that in fact this cut point does shift in the anticipated manner, When we increase P, we are shifting that cut point to the left so that A makes the risky demand under greater circumstances. And so the likelihood of war is going to be increased under those circumstances as compared to situations where P is relatively low. And again, that's because of the peace premium shifting. When P is next to 0, then A is going to be demanding the same thing regardless of whether it is trying to get the low value type to accept or the high value type to accept. And so that difference becomes very, very small. And so it might as well just make the safe demand instead and not risk having to fight a war and pay the costs associated with that. Hope you enjoyed this. Hope to see you next time. Take care.